Hello everyone, we're just going to do some review today over the two sections we've talked about, just so we know when to use which distribution and which, whether it's a z sub alpha over 2 or t sub alpha over 2. So I'm planning on a quiz Tuesday over section 7.1 and 7.2. On Monday we're going to start section 7.3. So I want you to pause the video, look back in your notes, and answer these first two topics. The first is to write out the three properties of a good estimator and then define what a point estimate is, as well as an interval estimate. All right, so pause the video if you need more time. But from our notes, three properties of a good estimator is that this estimator needs to be unbiased, consistent, and relatively efficient. So clearly the difference between a point estimate and an interval estimate, we could just go off of the words point and interval. A point is a specific value that will estimate a parameter. And the interval estimate is just giving us an interval or range of values used to estimate a parameter. All right, so next let's take a look at some examples. So for this first one, make a sketch of the normal distribution for a 90% confidence interval. State the value of alpha over 2 and where it's located on the curve. So pause the video to make the sketch and then resume playing. All right, and if you need more time, just pause again. So the key here, we're making a normal distribution, so we're looking at, not that we need the difference between a z or a t, but we're just looking at a normal distribution, so this is the z distribution. And 90% means that alpha would be 10%, and then we have to split it. So alpha over 2 is going to equal 5%. So that means the middle area here is the 90%. And then we're looking at 5%, which is the alpha over 2 right here, and another 5%, which is alpha over 2 right here. So when I ask a question like this is all I want you to sketch and label. All right, let's take a look at our next example. Please pause the video to copy this down. Remember, you need to determine if you're going to use the z distribution or the t distribution. So pause the video to work this out. All right, so let's see what you came up with, but if you need more time, pause the video again. Notice it says right here, the standard deviation of the population is given, so that's sigma. So this is from section 7.1, which means we're using z sub alpha over 2. All right, so we have a study of 42 ninth grade students show that they have played video games an average of 24 hours per week. So our sample size, n, is 42. X bar would be the 24. So we need to find z sub alpha over 2. So if we're looking at 95%, that means alpha would be 5%, and alpha over 2, 2.5%. So to type this in on the calculator, you're going to menu 553, type in 0.025. Remember in this, we don't need degrees of freedom. We only need that with the t distribution. So we should be getting, or you could look at back in your notes, because the 95% z sub alpha over 2 is always going to be 1.96. So then we'll set up our interval using the formula. So this means mu is going to be between, we'll start with x bar, so we have 24 minus 1.96 times sigma 15 over the square root of n, so 42, and then on the other side 24 plus 1.96 times 15 over the square root of 42. All right, then again, our x bar was given to us at 24, so we're going to round to the nearest whole number. So we should be getting a 19. That mu is between 19 and 29. So again, on the quiz, you'll be expected to write this statement. So we would say one can be 95% confident, and there's a couple ways to phrase this. That the population mean is between 19 and 29 games. That's probably the easiest way to write this. Or you could say that the mean number of video games played is between 19 and 29. All right, and let's try one more. Go ahead and copy this down. See what you need to do to construct a 92% confidence interval. Okay, and if you need more time, just pause the video again. Now for this, we're only given a sample, which means our population standard deviation is not mentioned at all in the problem, so we have to use the t distribution here. So you want to create a list and spreadsheet, type in those values. So if you didn't do that, or you use the wrong distribution, pause the video and retry this problem again. If you did do this though, you should get x bar is equal to 35.5. We need to go one more place value than our raw data here. S is equal to 24.2. We also need degrees of freedom here. So we've got 10 data values, so our degree of freedom is 9. Finding t sub alpha over 2 then. So 92% means alpha is 8%, alpha over 2 is 4%. So go to menu 556, type in 0.04, and degrees of freedom is 9. This should give us a 1.97 for the t sub alpha over 2. And then we'll set up the confidence interval. So mu should be between 35.5 minus 1.97 times 24.2 over square root of 10. And on the other side, we'll just add it. And we're calculating these. Again, we want to keep it rounded to the nearest tenth. So we have a 20.4. That mu is between that and 50.6. So again, we could phrase it the same way. Here we are dealing with unhealthy days. So the population mean, one can be 92% confident that the population mean is between 20.4 and 50.6 unhealthy days. All right, so if you still need to finish and check and correct worksheet 7.2, please do that. Also use this time to look back over section 7.1 and worksheet 7.1. That quiz will be on Tuesday. And then we will start section 7.3 on Monday. The reason I'm pushing the quiz till Tuesday is I'm going to be in the building, just not in class on Monday. So I won't be here for Zoom meetings for you guys to quiz. So we'll do the quiz on Tuesday, and we'll start 7.3 on Monday. Let me know if you guys have any questions.